Now we're going to sketch y squared equals f of x. Now there's two procedures here and we've already learnt both of them. We need to start by actually sketching the one we just did, y equals the square root of f of x. Because this is a lot like y squared equals f of x, except that in this one, we reasoned that y had to be greater than or equal to 0. And when we were graphing these, we found that we were ignoring anything below the x-axis because we couldn't take the square root of it. Then we'll need to double our graph around the x-axis so that we're keeping the upper half, but any negative values of y are going to share the same x value as those positive values of y. So it's a lot like when we converted y equals something into the absolute value of y equals something. We double the graph so that it sits below the x-axis. Now, how does this make sense and how are you going to remember what to do or understand what to do? Well, let's think of something that we already know. We know that x squared plus y squared equals r squared is a basic circle and it sits around the origin like this. And these points here would be r, r, negative r, and negative r. And we've already learned the formula for a semicircle. Now to get it, we've reasoned that if we subtract x squared from both sides here, we can convert this circle so that it looks like this. And this is still our circle, just rearranged a little bit. But if we take the square root of both sides, we have to consider that there'll be a positive square root and a negative square root. Now, which one do we want? Well, if we put both on like that, then we can say that these two equations are actually identical. And everything that is summed up by this one is also reproduced here. So this is in fact still our circle. But if we only take the positive square root by writing nothing there at all, then it means that we only actually want the upper semicircle. Whereas if we put a negative out the front, then we'd say, no, we don't want the upper semicircle, we want only the negative part, only the lower semicircle. So we've learned how to specify whether we want the upper or the lower semicircle using this formula. So starting with this and going backwards now, when we graph y equals the square root of something, it's almost like we're graphing our semicircle. And then when we go to graph y squared equals, it's like somebody said, no, let's graph the whole circle. We want the upper half and the lower half. Because all we're doing is squaring both sides, and that's saying, hey, it doesn't matter if we want the negative or positive, we're going to have both. And by doing this to it, squaring both sides, you're not changing the shape in any way. All you're doing is allowing y to be positive or negative, because when you square it, it will still equal everything on the right-hand side. So let's have a look at how this works. Here we've got our same graph, y equals f of x, that we've used lots of times now, basic parabola. We've already learned how to sketch y equals the square root of that. We ignored the section that was underneath the x-axis, and this section here ended up with this sort of shape. So now, if we've already got this one, the next step is to just take everything that's up the top and double it so that it also lies below. So take a few key points. We've got a few here that line up, and now we can see what's happening. And we need a shape like this that goes down below. Where's that going to go through? Somewhere like this. Okay, so we end up with all of this and all of this on both sides, and that will now be, the red part is all y squared equals f of x. Let's have another go. Here we've got a cubic curve, y equals f of x, so we want to start by graphing y equals the square root of f of x. Now, our key points, we want to ignore anything that's underneath the x-axis. So I'm literally going to start by actually rubbing that out so that my diagram's nice and clear for you. So we've got that part. And now we have to say, well, let's look for the zeros, because they'll still be zeros. Let's look for where y equals 1, because our new graph is still going to go through those points. Now we can reason that between 0 and 1, those y values, our new graph will lie above the old graph. Something like this will do. And over here, we're going to have something above. Whereas along here, we're going to have something below. And we've seen that if this one stretches up like this one will stretch out like that. So now we've got something. We've got y equals the square root of f of x. Now to graph y squared equals f of x, we are basically just saying take all of that, but now let's double it below. So that means this shape here is going to be repeated under there. And this shape here is going to be repeated down there. Now we can rub that out and say that everything in red is now y squared equals f of x. And remembering that we started with that cubic curve that went down like this. We can see the cubic curve in black, and we can see y squared equals f of x in red. So two procedures that you already know, just apply one and then apply the other. But always start with graphing y equals the square root of f of x first, then double it over.